Good morning to all. I am Dr. Dhondiba, Assistant Professor of Chemistry, Government First Grade College, Kyarpuram, Bengaluru. Today I am going to discuss about 21 session of chemistry and fourth session of surface chemistry, which belongs to third semester BSc, affiliated to Bengaluru North University. In this session, I have to discuss about heterogeneous catalysis, that is surface reactions and auto-catalyzed reactions. Now, the main objectives of these sessions are the meaning of surface reaction, explanation of unimolecular surface reaction, explanation of bimolecular surface reaction. Last one is auto-catalyzed reaction with example. That we have to discuss one by one in this session. After completion of this session, you will come to know about what is mean by surface reaction, then what is mean by unimolecular surface reaction, then you have already known about the bimolecular surface reaction, and you have to able to get knowledge about auto-catalyzed reaction, and you will be able to give that is any example for this reaction. This knowledge you will get after this completion of this session. Now, before going to discuss this session, you have already know about heterogeneous catalyst, then meaning of unimolecular reaction, meaning of bimolecular reaction, then why the pink color of KMNO4 is discharged slowly during the titration of KMNO4 against oxalic acid. These you have already known in previous session or in PUC level. Therefore, now coming to this session, now what is mean by heterogeneous catalysis as a surface reaction? Now reactions between gaseous reactants are catalyzed by the solid state catalysis. Means usually here reactants should be in gaseous state and solid act as a catalyst, and the reaction is called as a solid catalyzed reaction. The solid state catalysts are used in many large scale processes in chemical industries. The heterogeneous catalysis, in which the catalyst is in a different phase, usually solid is phase and gases are reactants. Therefore, usually heterogeneous catalyst reaction, the catalyst is in usually solid state and reactants will be in gaseous state. Therefore, they are in different phase, hence they are called as a heterogeneous catalyst, and the process is called as a heterogeneous catalysis. Now coming to that is a unimolecular surface reactions. Now a unimolecular surface reaction may involve a reaction between a molecule A of the reactant and a vacant site S on the surface. The mechanism may be represented systematically as follows. Then A plus S, it is formed, that is a AS, it is a adsorption, and Ka is nothing but rate of equilibrium constant of adsorption reaction, and that AS is back converted into, that is AS is further converted back into, that is reactant A, and that is a catalyst separate, that is a surface catalyst will be there. Therefore, AS is, that is a decompose, desorption will be takes place or evaporation will be takes place. That is it is called as a equilibrium constant of desorption, that is a K minus 1. Again this will be get, that is a product, that AS is directly converted into product by taking, that is the equilibrium constant K2. Therefore, AS is converted into product, and this will be called as a decomposition, means it is formation of products. Therefore, AS is converted into, that is a intermediate adsorption, and then this adsorbed that is a intermediate, they decompose to back come to the reactant, or it break down, decompose to form that is a product. Therefore, if decomposition will be takes place, that product will be formed. If it is a desorption will be takes place, that reactants will be formed. Therefore, here it will be a changes. If R is the rate of reaction, then according to Longmire Hinsfeld hypothesis, R is given by R is equal to K1 into K2 into, that is the molar concentration of the A, divided by K1 into molar concentration of the A plus, that is a K minus 1 plus K2. Call equation number 1. Equation 1, this can be written as, this equation can be written as, for our convent, that is making the reciprocal 1 by R means this will be get reciprocal, means how it is can be written as K1 into molar concentration of the A divided by K1 in the K1 K2 into A, that is a molar concentration of the A plus K minus 1 divided by K1 K2 into, that is a concentration plus K2 divided by K1 K2 into A molar concentration. Then what happened here, this molar concentration A and A get cancelled, K1 and K1 get cancelled, it remains K2 plus remains as it is here. Here there is no changing, therefore we are combining K1 K minus 1 plus K2 divided by K1 K2 into A molar concentration. Call equation number 2. According to the equation 2, this according to equation number 2, a graph is plotted for A by R versus A by molar concentration of the A would give a straight line with the intercept equal to 1 by K2, and the slope of the slope is equal to K minus 1 plus K2 divided by K1 K2. For gases adsorbate, the concentration is conveniently expressed in terms of partial pressure. That is same, suppose this is the solid will be there, that can be written as molar concentration. If it is in gaseous state, the adsorption, that will be expressed in terms of partial pressure. Therefore, that can be written as R is equal to K1 K2 into PA, that is partial pressure of A, divided by K1 into partial pressure of A plus K minus 1 plus K2. And similar to that is the previous equations, we can reciprocal to make this equation 1 by R. Therefore, we will get that is a 1 by K2 plus, that is a K minus 1 plus K2 divided by K1 K2 into PA. That is called equation number 4. This is equation number 3 and 4 are similar to equation number 1 and 2. It is difference is only here. This is the solid compound will be there. If it is a gas, this case it will be a gaseous state. Then come to that is let this is the limiting cases of equation 1. How? There are a few cases are there. The case 1, if the rate of decomposition is very large, then comparison with the rate of adsorption and desorption, that is K2 is very greater than K1 into the molar concentration of A plus K minus 1. Then the equation 1 becomes R is equal to K1 into molar concentration of A. This is called equation number 1, and this reaction indicate as the first order reaction with respect to A, because here A reactant will be there, therefore with respect to A. Therefore, it is a first order reaction with respect to A. In case 2, the rate of decomposition is very small in comparison with the rate of adsorption and desorption. That is K2 is very less than K1 into A concentration plus K minus 1. Then the equation 1 becomes the R is equal to K1 K2 into A divided by K1 into A plus K minus 1. This can be rearranged. Again, you have to making reciprocal 1 divided by R, and this will be cancel, and we will can write that is a K1 divided by K minus 1. That will be replaced written as that is a K prime, and after this we will get that is this equation. This will be I have written directly, but you have to make workout for this equation. No, this equation you have to make reciprocal 1 by R. Then we will get that is a K1 into A, that is molar concentration A, plus that is K minus 1 divided by K1, K2 molar concentration of A. Make it separate, then it will be some cancel, and then you have to take, you will get that is after again that is making that is a reciprocal, then we will get that is a K2 K prime, that is a molar concentration of A divided by K prime into molar concentration of A plus 1. This is can be written as K2, that is a K prime AP, that is a PA, means that is a partial pressure of A, that is a K prime divided by partial pressure of A plus 1. This is called equation number 6, where K prime is nothing but K1 divided by K1 minus 1 is the adsorption equilibrium constant. Now two situations arises depending on the pressure. At low pressure, when the reactant is slightly absorbed, that is a theta is going to 0, then K prime PA is very less than that is 1, so that it is neglected. Therefore R is equal to this equation becomes what is that? It became a K2 P prime PA equal to that is KPA, and this is equation number 7. This is the actually again first order reaction with respect to A. Here K1 is equal to K2 into K prime. Thus we can write that is R is equal to minus dPA divided by dt. This will be written as that is K into PA. Therefore this can be written as PA is equal to P to the power of 0 into A into EA to the power of minus KT. This can be written as, this is called equation number 8. This means that partial pressure of the gas decreases exponentially with the time. At high temperature, when the reactant is strongly absorbed, the theta is 1. Theta, that is will be a theta is 1, and that is K prime, and PA is very greater than 1, so that the R is equal to K. This reaction is called as a zero order reaction with respect to A. Thus we can write that is R is equal to minus dPA divided by dt is equal to K2. That is it is constant which can be neglected to give. That is PA is equal to PA naught minus K2T. This is called equation number 10. This means the partial pressure of the gas decreases linearly with time. Then this is the graph is there. The reaction rate, that is pressure. This will be at low it became a at low pressure it will became a first order. At high pressure it became a zero order. That can be explained in the unimolecular surface reaction. Now coming to that is we have to discuss about bimolecular surface reaction. A molecular surface reaction may involve a reaction between two molecules A and B reactants and a vacant site S on the surface. This mechanism can be represented as systematically below. The A is A plus A reactant plus that is a vacant site S, and it is formed that is a AS. It is a forward reaction and this is backward reaction. Equilibrium constant for forward reaction means that is adsorption, and the equilibrium constant for that is backward means it is a desorption. Again this site will be a attack to the other, that is a other reactant, and this will be a same, that is a K2 and K minus 2. That is a similarly adsorption and desorption for that is a BS, and therefore K3 is nothing but AS plus BS. It form that is a S and plus form that is a product, and this is the called as a K3 is the equilibrium constant for decomposition. If similar to above, that is a unimolecular, the bimolecular reaction, if R is the rate of the reaction, then according to the Langmuir-Hinsford hypothesis, R is given by, that is a K3, K1, K2 into that is a molar concentration of A into molar concentration of the B divided by 1 plus K1 into molar concentration of A plus K2 into molar concentration of B square. Expressing the concentration in terms of partial pressure and taking the proportionality constant as a unit for sake of our convenience of discussion. Then R is equal to K3, K1, K2, PA, PB divided by 1 plus K1, PA plus K2, PB square, because it is, this equation is in the form of partial pressure, and that can be written as, that is simplified, because K2, K1, K2 is nothing but these are all are constant, that can be written as K prime, that is K prime PA, PB divided by 1 plus K1, PA plus K2, PB to the power of square, where K prime is nothing but K3, K1, K2. Let us consider the following three cases. First case, when A and B are both weakly absorbed. In this case, the K1 P1 PA is very less than 1 and K2 PB is very less than 1, so that the equation 2 becomes, this equation becomes K is equal to, R is equal to K prime PA into PB. That is, the reaction is the first order reaction. First order reaction with respect to A and first order reaction with respect to B, and overall order of the reaction is second order. This is the one, this is the one. Therefore, with respect to A, it will be a first order, and with respect to B, it is second order, and sum it is takes place. Therefore, it is a second order reaction. This reaction between the reaction between the nitric oxide and oxygen on the glass surface belongs to this category. Therefore, this is the case. Now, case 2, when A is absorbed more strongly than B. In this case, the K1 PA is very greater than K2 PB, so that the equation 2 becomes R is equal to K prime K PA PB divided by 1 plus Ka PA to the power of square. This is called equation number 4. That is, the reaction is first order with respect to B. It is a reaction of the first order with respect to B, the weakly absorbed component. The reaction between hydrogen and carbon dioxide on platinum belongs to this category. This is the first order. This is because of it having a this is the, after simplifying we will get that is a, it is a first order with respect to B. Okay. Then case 3, when one reactant is very strongly absorbed, let A be the very strongly absorbed component, then K1 PA is greater than, that is a K2 PB, and K1 PA is greater with much greater than 1, then equation 2 becomes R is equal to K prime PA PB divided by K1 square PA square, and this can be written as K3 PB divided by PA. This is called equation number 5, where K3 is nothing but K prime divided by K1 square. This can be written as K3 K2 divided by K1. Therefore, the rate is inversely proportional to, we can say that is a rate is inversely proportional to the concentration of very strong absorbed component, because A is considering that is a, it is a strongly absorbed, no, therefore we say that it is a reciprocal there, therefore rate of the reaction is inversely proportional to the concentration of the strongly absorbed component. This is expressed by saying that the reaction is inhibited by such a component. The reaction between hydrogen and oxygen on platinum belongs to this category. Then last coming to that is a auto-catalyzed reaction. A certain reactions also get catalyzed by one of the products of the reaction is called, that is a auto-catalyzed reaction. They may ask in question, that is examination, what is mean by auto catalyzed reaction. Therefore, we say that certain reactions also get catalyzed by one of the product of the reaction is called auto catalyzed reaction. For example, in the oxidation of oxalic acid by potassium permanganate, manganese ion formed in the reaction catalyze the reaction. In absence of manganese plus 2 ions, the reaction proceeds very slow and permanganate ions are reduced to brown solid manganese dioxide, MnO4. In titration of KMnO4 against oxalic acid, the first few drops are always added very slowly to produce some manganese plus 2 ion to catalyze the reaction, because the initially the manganese ions are not present. Therefore, it cannot be discharged easily by adding the potassium permanganate from the burette to the conical flask containing oxalic acid. Therefore, the slowly we have to add, then sufficient number of manganese ions are produced, that then only it is catalyzed the reaction, and the rate of the discharge will be increases after some times. Therefore, this is called as a auto catalyzed reaction. Therefore, simply we say that certain reactions also get catalyzed by one of the products of the reaction is called auto catalyzed reaction. Here the reaction between, the example is reaction between oxalic acid and potassium permanganate, and manganese, it form no manganese plus 2 ion form in the product during the titration, no, that will be act as a, that is a auto catalyst, and that reaction itself is called as a auto catalyzed reaction. And so far we have discussed about meaning of the surface reaction, unimolecular surface reaction, bimolecular surface reaction, auto catalyzed reaction with examples. I hope you have already known everything this. Therefore, I will ask some questions you have to answer. The first question goes to, surface reaction takes place between A option, liquid state reactant and solid state catalyst. B option, gaseous state reactant and solid state catalyst. C option, solid state reactant and gaseous state catalyst. D option, solid state reactant and liquid state catalyst. I will give 10 seconds for you. You have to choose correct option. The B option is the right option for this reaction, because the reactant, the surface reaction takes place between the gaseous states are the reactant and solid state as a catalyst. Therefore, the B option is the right answer for this question. Then second question goes to, if the rate of decomposition unimolecular reaction is very large, high, then the order of the reaction is, if the rate of decomposition of unimolecular reaction is very large, then the order of the reaction will be a, which one? The high pressure, then it will be a zero order reaction. Therefore, that is the answer for this question will be a B option, that is the zero order of this reaction. Therefore, answer for this question is B option. Third option, when the reactant A and B are both weakly absorbed, the bimolecular reaction, then the order of the reaction is, that is A option 1, B option 0, C option 2, and D option none of these. I will give just 10 seconds for you people. You have to answer them. The C option is the right option for this question because it should be a bimolecular reaction. The reactants with respect to A is nothing but the first order, with respect to B is nothing but another first order, and overall rate of the reaction will be a, that is the second, that is a bimolecular reaction. Therefore, the option C is the right option for this question. Then fourth one, example for auto-catalyzed reaction is the reaction between potassium dichromate versus ferrous ammonium sulfate. B option, potassium permanganate and oxalic acid. Then sodium thiosulfate versus potassium dichromate, and D none of these. Just I will give 10 seconds for you people. You have to choose the correct option. The answer for this question is, that is the B option. The auto-catalyzed reaction is the reaction between potassium permanganate and oxalic acid. In this, manganese plus 2 ions will be formed. That manganese plus 2 ions act as a, that is a auto-catalyst for this reaction, and therefore this reaction is called as a auto-catalyzed reaction. And this completes, therefore this completes this session, and hence this also completed, that is gaseous state, and preparation of this session I have used these books for that, and thank you.